Okay, so we're going to talk today about some simplifying, pretty basic stuff in this section, stuff you've definitely done before. But you know, some things we have to talk about and have to practice just because it's been a while. Okay, so first of all, just our vocabulary here. We need to know term, constant term, variable term, coefficient, algebraic expression, and to decompose. So each one of these are terms. Which one is my constant term? -5. Why is that the constant term? How'd you know? Right, it doesn't have a variable. So therefore, then, my variable terms are the terms that have variables. So what's a coefficient? Give me an example from this problem. Which of a coefficient? 3, okay. What else? 7 and -6. So what are coefficients? The number in front of the variable. So sometimes the difference between constant and coefficient can get confusing. Coefficients are the numbers in front of variables. Constants are the numbers without a variable. And this is, no, there's not any. Okay. An algebraic expression is this whole thing. It's this whole thing. So what's the difference between an algebraic expression and an algebraic equation? Yeah. Yeah, equations have equal signs. So equations we solve, algebraic expressions we simplify. Okay, something else we'll talk about is standard form. So standard form of an algebraic expression puts your terms in order with the variables, and you look at the exponents. The exponents go in descending order, so from greatest to least. So we'll start with 7x cubed, and it would be 3x squared minus 6x and minus 5. So you can reorder an algebraic expression however you need to, as long as you keep the signs the same. And then sometimes when it's in standard form, we'll talk about the leading coefficient. So the leading coefficient is what? Some of you know. 7. It's the one in front. The one in front. And the constant is still -5. Okay, decompose. So that's maybe something you're not as familiar with. So it's to break into smaller parts. And that can be helpful sometimes when we are solving, just to manipulate our equations. So for example, plus 2 over 3. So what I want to do is I'm going to break this into smaller parts. Okay? So I'm going to break this to x over 3 plus 2 over 3. Okay, this x over 3, so something that you can do when you have a variable in a numerator is you can move the variable out of the numerator to the side. So your variable would be here. And we don't leave numerators empty. So if it is empty, we put a 1. So x over 3 is the same thing as 1/3 x. X divided by 3 is the same thing as 1/3 times x. So just knowing that you can take a variable out or put it back in the numerator can be helpful sometimes when we're solving. And then I'll just write plus 2/3. Okay? Questions about that? Okay. Now we're going to translate some written information into a mathematical statement. Now, this is something that's going to seem easy. Even when I do it up here, you're going to think, oh, I know how to do that. But it's something you really need to practice to make sure that you do know how to do it. At the end of notes, if there's time, which there should be, we're going to do some practice with your whiteboards. Okay, so 5 less than double a number. So let's actually pick a number. So let's say 10 is our number. So what is 5 less than double 10? 15. So what did you do first in your head? You doubled 10. You did 10 times 2. So, and then you did minus 5. So you need to make sure that that's what you're writing up here. When you see the word number, we'll put that in as an N. So when we're in Schoology and you're doing these, use N as your variable when you see number. Now if it tells you 5 less than 2 times x, use x. But if it has the word number, use N. Okay, so 5 less than double a number. So double means times 2. And then minus 5. And then minus 5. Now, it's very easy to read this and translate it as this, because the 5 is written first, but that is not the same. If you did this and our number was 10, you get negative 15. But that's not what it is. It was positive 15. It's this. So sometimes it can be helpful to actually pick a number, like 10, and do the math in your head, and that can help you write it down. Okay, look at the next one. Five times the difference of a number and 2 increased by 6. Okay, again, if our number is 10, what's the first thing we do to 10? Subtract 10, or subtract 2, sorry. Subtract 2. 5 times the difference, that means subtraction. So you do 10 minus 2, and then what? Multiply by 5, and then what? Add 6. Okay, so I need to make sure that's what I'm doing. So I have 5 times, so I have my difference of a number and 2, so here's my n minus 2. And then I do times 5, and increased by 6, I do plus 6. So I have to make sure that I do this first, but order of operations tells me that multiplying comes before subtraction. So how do I make sure that this is done first? Use parentheses. So I have to do this. 5 times n minus 2 in parentheses plus 6. Same thing if that had said sum. If that had said sum, you would have to use parentheses. So I'm going to write parentheses. If you see the word quantity, you're going to need parentheses. Like 2 times the quantity of a number and 2, like a number plus 2. Okay? Questions about these? Okay. Talk about evaluating algebraic expressions. So to evaluate means to plug a number in and get an answer. We're not solving for a variable. So I don't have like x equals a number. I'm just going to get a real number answer after simplifying. I have to plug it in and evaluate. Okay, so the work I want to see here. So the work that I would need to see on your quiz is I want to see the substitution, and then I can see your answer from there. You might have to do 1 or 2 extra steps, but typically you can go right from the substitution to your answer. That's why I had you grab a calculator. So anytime you plug a number in, use parentheses. So again, this seems like a really easy question. These questions are actually on the ACT too. But just by plugging it into your calculator wrong or writing it down wrong with parentheses, you can get the wrong answer pretty easily here. So to avoid making mistakes, this is what I say to do. Every time you plug in a number, plug it in with parentheses, and then type that whole thing in your calculator. So x is -2, so I'm plugging in -2. For x, I'm plugging in 4 for y. And everywhere I put those numbers, I put them in with parentheses, and I did not change anything else about the equation. So type all that in at one time. Don't try to group it because you could mess up with the negatives. That not work? Is it the batteries? All right, so you should get 40. You should get 40. Here's what I mean by making mistakes with this problem. If you try to do it, if you try to show too much work, so maybe you calculate this and you get 16, but you go ahead and write minus because you see a minus sign there, and then you type in -5 times -2 times 4, and you write -40 when actually it's +40 because a negative times a negative is positive. So be careful with your negatives and positives and the parentheses. That's why I say do this and then give your answer. Okay. Okay. All right, we're going to simplify by removing all grouping symbols and combine like terms. So removing all grouping symbols. Our grouping symbols are the parentheses. So we want to get rid of the parentheses. How do I do that? How do I get rid of the parentheses? And that's called to distribute. Yep. Yep. calculator. That's fine. These are fractions, so you need to keep your answer as fractions. So make sure that if you get a decimal, you change it back to a fraction. I know in like these old graphing calculators, you hit math, enter, enter. It'll change it back to a fraction for you. Just so you know, I'm going to talk through this without a calculator because once we start rationals, we have to know some properties of fractions. Okay, so 5, when you multiply fractions, multiply across top and bottom. So 5 times negative 2 is negative 10. 6 times 15 is 90. So I have negative 10 over 90, which reduces to negative 1/9. Okay, cute. And then 5 6 times 24. So I could put 24 over 1 and do the same thing that I just did. But what's easier, at least calculation in your head, is to go ahead and take this number, divide it by the denominator, and then multiply by the numerator. That's what you're doing by reducing, but it's just kind of easier, quicker steps. So 24 divided by 6 is 4. 4 times 5 is 20. Do I have any like terms? No. So this is done. How do I know I'm not solving here? There's no equal sign. I'm not trying to get the variable by itself, so don't do that. Don't make up an equal sign if there's not one there. The problem number, so this is 74 from R2. It's good to note that, so when you're doing those practice problems and you want to look back at the notes, you can see, because on the practice problems there's going to be like 75 or 73, and you'll have to do one that's similar to this. So you might want to look back at the problems. Okay, so this is 78. So 5/12 y and negative 3/8 y are like terms. They both have y. So you can just subtract those. You can just combine them, and that's your answer. I will show you how to do it without the calculator. So if I'm going to subtract fractions, I have to have a least common denominator. So what's my least common denominator between 12 and 8? 24. Yep, 24. Okay, so for 5/12, for 12 to get 24, I have to multiply it by. I need to keep this the same equation. I can't change like the value of it, so I have to multiply it by 1, which is 2 over 2. All right, what do I have to multiply 8 by to get 24? And so I have to do 3 over 3. Okay, so 5 times 2 is 10. And then negative 3 times 3 is negative 9. Now we can subtract. When you subtract with the common denominator, subtract across the top. And your denominator stays the same. So 1 over 24y. This also can be written as y over 24. Remember, knowing how you can pull the variable out or put it back is helpful later on. Questions about that? Okay, we're going to do 2 more problems in your notes, and then we're going to do some practices with the whiteboards. So the directions are the same. Simplify by removing all grouping symbols and combine like terms. So I have to get rid of the parentheses. I'm going to distribute. But what am I going to distribute? The negative, or -1. This n squared is a different term than that -1 right there. So what I distribute is the -1. The n squared just comes down. So -1 times 5n is -5n. -1 times -4n squared is positive 4n squared. Do I have any like terms? The n squared. So that's 5n squared. And then I just bring the -5n down. Don't get too ahead of yourself and think then you need a factor. We're trying to get rid of parentheses, not add more parentheses, so we're done at this point. Okay, so let's look at another one. Yeah, I think they're in there. Okay, we're going to learn in R3 to multiply binomials times trinomials. So we're going to learn to do this. This binomial times this trinomial. This problem is not that. We're not doing that there. Don't put those parentheses there or act like they're there if they're not. So what I'm multiplying by this trinomial is just -2, not n minus 2. I'm not multiplying the n as well. So order of operations says I multiply before I can, add or subtract. So I'm multiplying the -2. And so this n just comes down. So that seems like a simple thing, but it is a really common mistake. Especially after we go over binomials times trinomials, then your brain just wants to tell you that that's what you should do here. But don't put the parentheses there if they're not. If you are supposed to multiply both, then there would be parentheses around it already. Okay, combine your like terms and put it in standard form. So write the -2n squared first. Okay, is that what you got? Okay. Questions about that? Okay. You can put your notes away.